What's going on, YouTube? Hope you've all been excellent. Hope everything's been well. Today we're going to be doing something completely new for me. We're going to be building an RC car. It's entirely 3D printed, minus the suspension and the motor and stuff, but it's a very fun project. It's just a lot of fun. It was totally new for me. Here it is, ripping through the gravel. And I just want to say right off the bat, this is not my design. The guy who made this, he goes by the handle Engineering Nonsense, and this is his 5th rendition. He's super talented. But when I was building this, there just wasn't a complete guide of like how to assemble everything. So that's what I set out here to do today. Like always, you try to make the video really organized this time, so it's not going to be a giant headache. And what do you know? Sure enough, it turns into like just a giant mess. But like Mr. Beast once said, just make 100 videos and make each one better than the last. So, thank you for your patience. Hope you guys enjoy. This thing was honestly just wicked fast. My footage just really doesn't do it justice. When you turn up the speed on the motor, it's just nuts. And like this motor that they use in the build is just so crazy. Like you've got to limit it to like 60, 70% or things just start breaking. But like, I don't know what the top speed is, but it must be doing like 60, maybe faster, maybe 70. I'm not even sure. But I've never experienced this.
Not the greatest way to go ahead.
Print a lot of this. It's Performance PETG. And now that leads us to developing the next component, which is the CV joint, as Google Gemini says I would call it, constant velocity joint. So it's very creative how he designed this. He's using 6mm steel balls and making kind of like a bearing function. It was really impressive. It was tricky to get assembled, so you're starting off with the hardest part. I promise it gets easier from here. I found a good way of getting 3 in and then just kind of pushing the 4th in just like that. Nice satisfying click. And here you can see the action. Very clever, just, you know, tons of respect. And so that's all assembled. Now the rest is going to be easier. All right, moving on. Here we're going on to part 2. I'm still writing it out for you, so don't get used to all this. But jokes aside, we're going to be assembling the knuckle here. And so we're just pressing on these bearings And see that thing on the right, the larger component it's pressing into? Just got to keep note of the orientation, because I did install that upside down. So we'll see that in a second, but you just want to press these bearings in, and it was moving pretty smooth. So now here's like kind of like a little locking plate, and the tolerances were just right. That pushes on. Later on, I didn't end up having to modify that component, as the wheels I had chosen, they're so deep that there was kind of some rubbing going on, so I had to extend those. But regardless to say, we're just putting on a little nut right now, which clamps on the wheel onto the 12mm hex. Alright, so now moving on, we're grabbing this TPU piece, and we've got these size screws. I think you're just going to have to eyeball them. It's pretty self-explanatory, and we're just putting on the upper and lower control arms here, I believe you would call them. So you do have to drill them out, and that was something kind of I learned the hard way, where my suspension just wasn't really seeming to actually function. But I realized that I needed to drill some components out, not all of them, just so that they would move a little more. All right, so lost footage of this one, but we're taking that little smaller piece and we're inserting it into this large gear here, and here I'm just pretending to tighten some screws. All right, so now grab this guy you assembled earlier, and now your little TPU torque damper, and we're just going to press it on. This was another component that I ended up having to modify because it kept breaking, so I beefed that up in Fusion 360, and I can provide that in the description if anybody wants. All right, so now we're just fitting some bearings on there, and these guys just pressed together. Pretty cool fit. So I was starting to get excited. It was looking pretty cool here. And yeah, just throwing on the other TPU torque damper, which kind of damps the torque going to the wheels. Very, very clever. Yeah, I was just getting excited. And so now we grab our gray PETG housing, drop it in there, and it's perfect fit, spinning nicely. So for the next step, we're just getting out some M3 nylon lock nuts, I believe. And we've got the 3mm threaded rods. So this was something I actually ended up having to modify in the end. The design only called for just one nut on these rods, but I found that when I was doing some work elsewhere, the rod was spinning and kind of loosening. So what I ended up doing was attaching two nuts against each other so that they would lock. So I made a little mistake here because the videos I was following were incorrect. They only showed 2 rods going in, but there should be a little title on the screen saying to put 3 rods, okay? So this is a mistake. You definitely want 3 rods. There's 3 holes. And okay, so here's an example of the 2 little nylon nuts acting against each other. So then when we work on the other side of the 3mm rod, it won't just kind of unscrew from these nuts. All right, so moving on, we're just going to continue to assemble the rear part of the car. So you should have these guys laid out in front of you, TPU in gray, PETG in blue. So just kind of showing you the orientation here to make it real easy, because it wasn't so simple when I did it, but that's what I'm hoping to do here. All right, so slide these 3 M3 rods through, not 2. Slide those guys up, should align real nicely. This is just a little clip showing a teardown I did later on to fix something, and it's just kind of demonstrating the 3 rods are in there. Yeah, pretty self-explanatory. All right, moving on. Okay, so now we just want to grab this assembly that we made in the previous step, and please take special note. I did make another mistake. See on the left how the upper and lower control arms are alternating. There's holes on the bottom and no holes on top. So one is flipped, and the other just stays in that same position. All right, so now we're just adding this blue piece on top here, and this will allow the suspension to mount to it. So don't just gun it in, use the Allen keys so you don't strip the plastic. And I'll put up a little picture here on the left just so you're aware of the mistake and how it should look, how it should be oriented. Okay, so moving on, you should have these components laid out in front of you, And now we are going to fit the wheels. So like I mentioned earlier, you want to take special note of the orientation of that little thing connected to the wheel. I believe it should be pointed up. There's like a little curvature on it. All right, so now we're just screwing in these long M4 screws. I don't know what I was doing here, trying to do this all by hand. I eventually used the gun, but just be careful that it doesn't not align with the control arm on the other side and snap the little arm off. That happened to me a couple times. Okay, so moving on, you can hear my laptop ready to catch on fire in the background, but we will grab this little motor housing and we're just gonna push it into the TPU there and then thread it in with these M4 screws. Not too much to see here, you get the picture. Just gotta fill the dialogue in, righty-tighty, lefty-loosey, okay? So don't forget, cue the speed montage. Finally, let's make this video a little faster. So we're just installing the rear suspension. And I did cheap out on the suspension a little bit just because it was getting expensive, but it still worked. All right, so now moving on to the motor finally. So see what I'm trying to show there is there's a big belly on that blue piece, and I'm trying to show you that the phase wires are coming out in that orientation. They're on that side. So on the motor, there's these threaded holes. When we just line them up with the 3D printed part, and we throw in these M3 screws. So I'm tightening them in a star formation. And this is helpful because if you don't and you tighten one side at a time, then the other side will actually become loose. So as you get close to a torque you're happy with, just go in a star pattern. Okay, moving on. We're moving on to the pinion gear. So things are starting to get exciting. So now we've got this little guy here and there's these setting screws in it. So we're gonna remove those, and this is pretty critical. You wanna line up those holes for the setting screw with the holes on the pinion gear because it's a very, very tight fit. And once you get it in there, good luck. It's probably not coming out. I mean, you can get it out, but it's just a headache, right? So you want to get that guy lined up, push down on it, and satisfying click. Ah, so good. Okay, moving on. Now we're gonna put it onto the shaft. But one problem, the motor shaft doesn't have a flat spot for these setting screws to push up against. So we need to make one. All right, so we're gonna put the pinion gear on the motor, and then we're gonna take apart a little pen, and we're gonna try to mark where on the rotor we should file in a little flat spot. So do what you gotta do. This worked for me, and yeah, I got it all working, but it's a labor of love here, okay? You're gonna have to take that little file, and yeah, I also filed down part of my thumb, which was good, but eventually I got a nice flat spot on the rotor and a pretty secure mount for that pinion gear. Here you can see it. All right, so now we're tightening in those setting screws. I make it look so easy here. I deleted tons of footage of me just struggling because they weren't perfectly aligned, but we got it. Okay, loosening up the motor mount, and we're going to put this bearing in for the other end of the pinion gear to help the torque of it so it's not bending. I think that's the words you would use. It's a long day. All right, pushing in the motor, and now we're gonna tighten these screws to secure the motor to the motor mount. All right, more TPU. Eyeball up the screws on the screen because I'm not writing them down anymore. I'm kind of losing my hair over here. And gun them in, okay? So now we're just throwing in these longer screws into the TPU, and yeah, likewise we did earlier, throwing on this piece that the suspension will attach to. I did it with the gun up until it got tight, and then I did it by feel with the Allen keys. You should always do that. So better late than never, here I am trying to show you the orientation of the upper and lower control arms so you don't make the same mistakes that I made, okay? So they're alternating, okay? And yep, now I'm just screwing in the M4 screws into the TPU on the other side. And be pretty careful here because this stuff's very soft. You can even just push the TPU right over the screws, but it's definitely best to try to thread them in just so you don't damage those holes in the TPU. Here I'm just showing how I had to modify the little 12mm hex to compensate for how deep my wheels were and how it was rubbing. So of course I had to make more spacers. Getting the distance just right was tricky. was doing it in software at first, but then I realized I could just cancel the print when it looked about right. So, all right, throwing on the little nylon hex nut to lock the wheel. So I'm trying to show you, make careful note of the orientation here. So one is pointing down, one is pointing up. You're gonna have to eye them up, okay? Just like how you see on the picture here is how you wanna have them on your end. I'm using the drill here to set these guys in, but just be careful you don't strip the plastic there. Okay, so taking special note of the configuration here, line them up to the upper and lower control arms, and sink these M4 bolts through. Taking special care not to snap the other end of the control arm off if the screw is misaligned, by the way. Cue the speed montage. So we're going to be throwing on the suspension. Let's get this project moving. So I also put the suspension on upside down in one of these attempts. So take special note of the way you see it here. And yeah, get that all tightened up. Not too tight though. You don't want to strip that plastic. All right, moving on to the servo configuration. I recorded this one in time lapse only, so you're gonna have to kind of follow along here. But you just drop it in. It's pretty self-explanatory. And then there's these arms that attach, right, in the blue. And in a second, I'm gonna show you the configuration, right? So you just kind of have to pause the video and look at how they are. And it'll be pretty self-explanatory. So get this guy screwed on there. It was a little bit finicky, but with some patience, you can do it. And here I am showing the orientation. So just like that, flip them up, just position it exactly as you see here. Eyeball up these screws because I'm not that nice, and sink them in nice and carefully. And now attach the other end of that blue guy over to the rod that connects directly to the servo motor. As always, careful not to strip the plastic here. Don't overdo it. So at last, we've got it all done, and you can see how the mechanism works here. Pretty neat to see. Okay, so moving on, we've got these guys part of the steering suspension. So I'm trying to take special note of the orientation here to show you that you want that flat spot up, or however it is. As you see on the screen, here's a modification I actually had to do because Engineering Nonsense designed it to print in place. But there was such a gap there that the steering was real sloppy. So somebody online developed these, and I actually kind of came up with this method here of printing them separately in just a tighter tolerance, putting some grease on and clamping them together. And luckily it worked. Now there's like no slack in the steering, which was good, but it does require a little clamp. You could probably use a book and just step on it, something like that, but definitely a good upgrade. All right, so now grab your steering mechanism and throw it on the 3 M3 rods, not the 2. Mistake on screen here. And things are starting to move along. I don't know if I showed this, but I slid on the body earlier, the body that houses the battery. So pretty self-explanatory. Now grab your front wheel set that we made earlier. We're getting close, guys, we're getting close. So throw this guy on. I made it look real easy, but some parts were a bit of a struggle. And now we're throwing on the very front bumper cap. Cue some lighting for your shot to make it look real pretty. And let's go to installing the electronics. So I'm just cleaning the surfaces with rubbing alcohol just so the double-sided tape will really adhere. Those are some TPU wheels you see on there that I spent forever printing and making. They were fun. It's fun if you have like hardwood floors you want to slide around on, or if you have like large, thick grass you want to go over. It was pretty fun. Okay, so I missed all the footage, but you can see how it is just laying it all out here. So I've got the receiver and the receiver antennas just kind of zip tied there. There's my transmitter. So I didn't know anything about this stuff. I just went right on Google Gemini and I asked questions about how to set. Because as soon as I connected it all with doing zero research, I found that my steering was going the wrong way. My wheels were spinning in reverse. So here I'm just kind of showing you on the FlySky FSIA6B, I believe it is, how you can kind of reverse some of these channels. And then I also had to do a fail-safe, which was good in case you ever lose connection. It won't just continue driving away. And here I am kind of setting some of the limits for the servo motor, and most importantly to turn down the motor speed, because if you go at 100% speed with this crazy brushless motor, like, things will break. It's not an if. Things will absolutely break. And yeah, so my first time ever setting up RC electronics, seeing it working was pretty cool. I'm new to this transmitter and transmitters in general. There's 10 channels on this, I believe, some switches on the top, and you can set up things like lights or anything you can imagine. Little modules for controlling lights with these guys. Ordered some, but I'm yet to set them up. Okay, let's move on with this project. All right, back to installing the electronics. It was a little tricky to get the ESC mounted because there's no real holes or mounting accessories on it, but I used 3M double-sided tape on the bottom, and then I did kind of like an X over the top with these zip ties, and it was very secure. And cleaning it with rubbing alcohol just to make sure the tape adheres super securely. Don't cheap out on double-sided tape. 3M stuff, a little bit more expensive, but it's super secure. Cut the zip ties, clean it all up as best as you can. It's still an ugly wiry mess, but hey, it is what it is. Little clip of the ESC that I used for some reason, just thought you should see it again. It's yeah, it was a good one. Don't cheap out on these. I've heard a lot of reviews of things like that breaking. It's got a little cooling fan on the top there, and I've been using it for a few months, no issues. Okay, so now we are just kind of securing down some of the other components with 3M double-sided tape, and yeah, cable management, just kind of using some of this clear Gorilla tape just to bunch up some of the excess cables. Get it looking how you like it. However, it's nice and pretty to you is all that matters. All right, now here's some batteries that I have. I actually found these in the garbage. I know, it's crazy. I think they're like $50 each. But this project can use 3S or 2S. 3S is a lot more power. Very easy to break stuff with a 3S and this specific motor. But hey, what I've come to learn is that RC hobby is about going out and breaking it within the first 5 minutes and then going back in and doing more R&D. So what was I trying to show here is that it's got 5,000 milliamp hours and 50 C. So the C rating is a measurement of current output. So we can actually find the max current that our battery can output if we multiply the C rating times the battery capacity. So we've got 5,000 milliamp hours. If we divide by 1,000, we get 5 amp hours times 50 C, which is in theory 250 amps. So these are pretty high performance batteries. So here's just a little clip of the kind of charger that you have to use to charge these batteries. So be very careful you get the right settings because you can overcharge them, but it's a Hobby Fans B6. Mine is a knockoff, but this is what you want to get. And so you'll connect the actual battery cables to it, and then you also connect these balance leads, and that will charge up the individual series batteries inside your battery to equal voltage. And that's just a little tidbit of information, but it's important. So here's back to the TPU wheels. These were a lot of fun. Took a long time to print, and whoever designed them did a really good job because they screwed together super well. And they were fun to mess around with, fun if you have hardwood floors or if you're trying to save some money. They also did really well in tall grass, which was just kind of fun to mess around with because RC wheels can be pretty expensive. That's what I found. So here's a little clip of the TPU torque damper arms. So these kept breaking, especially when I put on these TPU wheels because they had so much traction that the power goes up the line and breaks the next component, right? If the wheels can't spin. So here's what I mentioned earlier. I redesigned them and kind of beefed them up, and these will never break. But now that means the power goes up the line and breaks something else, right? So here I'm just showing the pinion failure. Just goes up the powertrain. It was really interesting. You kind of learned a lot about vehicles and rear-wheel drive dynamics through this project. It was kind of cool. And here I'm showing the resilience of that main gear. I'm surprised I'm still on the first one. This was an idea I had. I tried to redesign the pinion with a fan blades on it to cool down the motor. I don't know if it actually worked, but it was fun. Heating up the motor was something that I noticed would happen. It would get like way too hot, especially on summer days, so just keep an eye on that. And more failures. This is what the hobby's about, so that's what I found. This was a real weak component, and it has to do with the orientation in which the 3D prints these. Some are in line and some are against the grain, just due to the odd shape. So that is a failure point. You just want to keep a few of those in the bag and be able to replace it on the fly. So like I mentioned earlier, before I went and redesigned those steering arms, I'll call them, there was actually a lot of play in the print in place kind of ball and socket joint. So I'm just showing that how much play there was. That's definitely an upgrade you want to make with the the better tolerance ones. It made the steering just so much tighter. All right, everybody, that pretty much wraps it up. I just want to say thank you so much for watching. If you're still here at this point, you're a true fan. This project was so much fun. This is my dad using the RC car. He's 70 years old. It was just so much fun just to build this and then take it out with your friends and family, your nieces, your nephews, and everybody just had a blast trying it. I think it's been so long since we've ever messed with RC stuff that it's just like surprising how fun it is. And surprising how fun it is with friends and family. But once again, thank you so much for watching. This video took me a lot of work and a lot of time, a lot of headache, probably lost a few hairs. But if you could just please hit the like button, that would really help me out. And if you want to subscribe, there'll be more content like this on the way. And appreciate it so much, guys. Hope you all have a wonderful day. Thanks for watching.
They also got to get back into the water.